Essential question, how do I simplify the natural log expressions in solving PERT equations? So exponential functions with base e. Exponential functions with base e as a base have the same properties as the functions we've already studied. The graph of the function f of x equals e to the x is just very similar to a function of base 3. The reason why is e is an irrational number that I just highlighted there in the purple. And we say e is approximately 2.72 when we round it to three significant figures. So 2.72 is very close to 3. So what we see here is our exponential function f of x equals e to the x. How we can graph this out by hand is a table of values. And we would just substitute some numbers in. So -1, e to the -1 is 1 over e, or 1 over 2.72. So right about there. If I substitute 0 in for x, e to the 0, anything raised to 0 power is 1. So that's that point right there. If I substitute 1 in for x, e to the first. So again, e is approximately 2.72. So that is right there. So what we get is a graph that looks like that, and then it has an asymptote at y equals 0. And then again, here's the domain and the range. The domain is all real numbers. The range is everything above that horizontal asymptote. A logarithm with base e is called the natural log, as abbreviated as ln. It can also be written log of e. Natural logs have the same properties as logs of base 10 and any other bases. The natural log function can be reflected across our line of symmetry. So notice here in the blue, I'm just going to color it in black. So that's the graph that we did on the previous slide, right here. So right there in purple. Then what we would do is we would take those ordered pairs and we would reflect them. We would interchange them. And what we get is a logarithm that looks like that, graphed out. Notice its domain is x greater than 0, cannot be a negative number. And then now the range is all real numbers. So I'm just going to take a quick sketch of just the natural log. So here is our natural log function graphed out, ln of x, or y equals log base e of x. They're the same thing. What's not shown on this graph is there's actually a vertical asymptote at x equals 0. So then when we have the domain, it's going to be everything to the right of that purple imaginary line. So that's our domain, everything greater than 0. And then our range of values now is all real numbers. Where here, our domain is all real numbers, and then our range is everything above that horizontal asymptote.